Okay, we're going to start up a feed pump. It's going to be B Bravo feed pump. This is the load demand computer. Right now the plant load is at about 295 megawatts gross. We've been requested to go to 400. So we'll type in 400. megawatts. Right now we're in boiler follower 2 with the megawatt loop in. The turbine valves are trying to hold the megawatts. That's what we have set. And the boiler will follow, trying to maintain 2400 psi. Okay, we're going to hit go. We're going to go 3 megawatts a minute increase. Okay, now we're going to go to the feed pump. We had the operators close the warm-up valves. You can see the temperature is about 360 degrees on the running feed pump, so that's why it's important to keep your feed pump warm. As metal heats up, it expands. It can change alignments and clearances in the pump. If it's cold, then you heat it with hot water. So there's a warm-up on your main feed pump and your booster pump. Here's your deaerator storage tank, your booster pump, feed water heater 5, feed water heater 6, main pump, feed water heater 7, and then it goes up to your lower economizer. This is a level control valve we kind of mentioned. Startup feed pump. This is only used for starting up. It will maintain a level in the boiler drum for startup. Right now we're on 3-element control. We're looking at steam flow, feed water flow, and the drum level is correcting it. You can see we have a graph up. You always want to have graphs and charts before you start anything. It can give you a good indication of what's going on and where you are. We're going to check the recirc valves. They are in auto and they are open. This is the booster pump recirc. As you can see, we are in kpph, not gallons a minute. All the water flows on this is kpph, but gallons a minute are more familiar to a lot of people. This is the main pump recirc. We're in auto, it's set. It's going to try and maintain 750 kpph. This is the seal water valves. We're maintaining a 15-pound differential pressure on the feed pump seal coming off the condensate pump. Before we started this, we announced it to the plant personnel we were starting a feed pump. So it's a good idea to announce that you're starting equipment in case anybody's in the area. Okay, here's our main screen. We're going to go to boiler feed pump B. We'll go down the lube oil screen first. Okay, the turning gear is on. The feed pump needs to be on turning gear for 3-4 hours to take any bow out of the rotor shaft. It's a small turbine, so there's not a lot of bow. We have less than 3 mils eccentricity, which is within limits to start. You can see we have bearing vibrations. Here's your turning gear. It's your main feed pump. Here's your steam turbine. Here's your thrust bearing. This is where we have the positions. Make sure you're not going to crash your rotor into the diaphragms. Here's the gearbox. Here's your booster pump. The booster pump will run 3600 RPM while the feed pump's running 5825 RPM. The gearbox drops the speed. Oil temperature is 70 degrees. That's okay. A little colder than we would like, but it's within specs. Okay, we're checking the lube oil pump. It is in auto. This is the backup AC pump. This is the DC pump. It runs 250 volts DC. This is to shut the turbine down if you lose AC power. It's only to protect the turbine and bearings, this guy. You cannot run with it. Okay, everything looks good. We're going to go to the B feed pump. Right now it's showing tripped. These are your valves we showed on the turbine screen. You have your low pressure stop valve, low pressure control valve, high pressure stop, high pressure control. These were those 4 valves. The stop valves have the dump valve under low pressure that will slam shut. When we latch, we're going to reset those solenoid valves. We now have hydraulic pressure available to run our valves. We're going to open the low pressure stop valve and the high pressure stop valve. Our control valves are still closed. It'll be running on the low pressure side as we have plenty of steam. If this was a plant startup, this would go open. It gets about 75–80%, and the high pressure valve would start opening to run the pump. We go to control mode. We're going to use a thing called the speed setter. This will control the turbine speed up to minimum flow conditions. The booster pump only doesn't put out enough water at low speeds to run the feed pump. And there's also a critical speed at 2,500 on the turbine. Okay, we're going to go to 2,900 RPM. We're going to go 800 RPM a minute. We've entered them. And when we hit go, the control valve should start opening and control the turbine speed coming up. Okay, you can see the speed starting to come up. This is the set point. This is actually what it's doing. We'll go back to the lube oil screen and watch vibrations. A person in the field is just observing for any unusual noises, sounds. These pumps, like I say, can be started twice a day. Most of the time it's early in the morning when this is the last thing you really want to do. But you have to come up and catch peak load. 2 feed pumps will run the plant to 580 megawatts net. And you get down below 270 megawatts gross, you drop 1 feed pump. There's 2 terms on megawatts. We'll use the word gross. This is the actual generator output, and net's the amount of power going down the line. This plant can take 30 megawatts for full load operation, time you run all your fans and different equipment, circuit water pumps. See the speed coming up. One thing, you should use the phonetic alphabet, like this is Bravo, A's Alpha. There's always the case when somebody is supposed to go out and work on a piece of equipment called E, and next thing you know, D's doing something weird. So it's just a good idea to announce it and get in the habit of using phonetic alphabets. It minimizes problems, especially with radio. Radios are very difficult to hear anyhow. You can see the speed is coming up. We have our graph. This is the suction flow. It's the total steam flow. And we have our feed water. There's the drum level and feed water flow. The scaling's off a little bit on the feed water flow to steam flow. So we're going to correct that here real quick. It's kind of nice with the graphs nowadays. You can make a lot of changes and a lot of stuff compared to the old days when you just had pneumatic controls. Okay, this is in kpph. Both your feed water and your steam flow will have the same scale. So you can see we're pretty close. If these much of a variation in these, your drum level is going to start swinging. One thing you don't want to do is run your drum level too high or too low. You won't be able to start another igniter. That's a vapor extractor. This helps pull the slight vacuum to keep oil from leaking out of the bearings. All your bearings have slight negative pressure. And on the pictures of the plant, you'll notice only one oil line. That's because the supply line runs up to inside the oil line and return comes down the outside, inside this pipe. That way, if there's a leak, the oil stays in the system. It's called guarded oil. Really important with steam turbines. It's been some major fires, major problems from oil leaks. Very hard to put out if you have a major oil leak on a large turbine generator. Oil temperature's coming up. We're at our speed, 2900. Vibrations look good. The rotor positions look good. There's no weird axial loads. The feed pump seems to be running okay. Yeah, we'll tweak this a little bit. One thing nice about these graphics, you can move stuff into a lot with it, a lot better than the old panel boards. Okay, you can see we got our both stop valves are open and our low pressure control valves in travel. High pressure steam control valve is closed. Like I say, if we're unable to make it with low pressure steam, then high pressure would take over. It's pretty much a bumpless transfer. Okay, we go to control mode. We're going to take the speed setter out and go to remote control. Okay, we have remote control. This is controlling the feed pump speed and drum level. This is our drum level set point on this one, and this one here you can bias off it. If it's running or not, you can control the drum level. Okay, we're in manual. We're going to drive it up fairly fast. That's just to give the booster pump more speed so it'll catch up with the flow. These are pretty durable steam turbines. We usually would test the stop valves to restart the turbine, but this was just shut down 12 hours ago. And when they shut down, the trip valves go closed. And you do this every day. You kind of know what numbers to set. 47% speed on this one. It kind of depends on who the shift supervisor is, what you're going to really do. They have different opinions on things. Some want to run an auto, but it swings it too much. It's best to have things in auto as quick as you can. In manual, it's something you got to remember to pay attention to, and it's easy to forget it. Okay, we're going back to auto. You always got to highlight your box before you go. A lot of times in a crisis, you'll be trying to click on this and nothing will happen because you're not highlighted. So, okay, here's our feed water flow. You can see the feed water shot up when we had both pumps running. This is the A alpha pump coming down. This is the B Bravo pump coming up. Total steam flow. There's your drum level. It should be catching up. Quick check, both pumps are running about the same speed. So far, it's come up to 341 megawatts. Throttle pressure is 2400 psi. Furnace pressure is a minus 0.5 inches. Drum level is negative 0.2, which is good. Superheats 954 and reheats 877. Total fuels 444. Air's 51. O2 is 3.13. Usually your O2 is higher at low loads for furnace conditions. You always want your air above the fuel. If you go to 0 on your O2, cut fuel. Don't ever trip the boiler. It could blow up on you. Now look at our graph, see what we're doing. So far it looks okay. Feed water's coming up. Probably could have went a little bit more on the pumps when we put it in, but drum level's not bad. Minus 15 inches, the plant will trip. So that's a number you never really want to see up here. As long as we're above minus 4 inches on this, we can start another igniter. Feed water flows quite a bit under the steam flow still, but it is catching up with it. This is the advantage of graphs. You can track a lot of information. Any weird changes, you'll see a change in your graphs. You can realize there's something you need to be looking at. And that concludes the startup of a feed pump. We're on the way to 400 megawatts net, which will be about 370 net megawatts, 400 gross. Okay, we're going to demonstrate what happens when you lose a feed pump. This is a simulator. Do not try this with your plant. You'll probably be looking for a new job or have something named after you. Okay, we have 500 megawatts. We're boiler follower 2 with the megawatt loop in. Basically have 6 pulverizers running. And basically you'd be sitting here looking at your LDC screen. Try it. Okay, we'll go to the screen. This is what you see. This is what comes in. Now, what just happened? It's kind of hard to figure out with all these alarms, so you got to sort through alarms really quick and find out what was the real problem. This is what you're going to see is the bottom part of this. Usually these are gone real quick. We know we've lost a couple pulverizers went down. We know something bad's happened in the plant. If you're lucky, you can see this up here that your turbine is tripped. We'll go to the LDC screen. See, we have a run back in progress. It's in turbine follower 2. The fuel is driving down to 43%, I believe, on this. And the turbine pressure is going to follow, try to control it. We have a boiler feed pump run back in right now. Drum level, it's minus 2.6. This is going to be the major problem right here. In order to save the plant, we should probably trip some more pulverizers, but this is up to the plant management if they'll let you go outside the bounds of the plant safety. Four pulverizers, G and C have tripped off. I don't have any idea why the feed pump tripped normally. We're down 4.1. Fuel's driven back to 42. And the drum pressure is 2461. Turbine valves are trying to control that. Down to 420, about 430 megawatts. It's coming up a little bit to bring down the pressure. We have 59 alarms just come in. So you go back to your screen, you'll see your feed pump was one of the first alarms that come in. Started a boiler feed pump run back. Your pulverizer's tripping was part of the run back. It drops down to the bottom 4 pulverizers running. So these alarms are to be expected. The problem in plant upset is trying to determine what happened quickly. Now there's a lot of other things going on. Our steam pressure's climbing. Drum level's 5.9. You may catch it. This is kind of a safety contingency function that if you lose a piece of equipment, the plant will run back to a set fuel load on the boiler, then your turbine will try to control the pressure. As your feed pumps only maintain can supply half of your boiler water level at half load, you have to go to one feed pump and the plant has to come back to half load. So far drum level looks pretty good. It actually might hold it. We'll check the feed pump, make sure it's not running too hard, getting ready to trip. Yeah, it's 5930 RPM. It's running pretty hard. So we're still in a run back. Drum level's not dropping very fast. I think we'll be okay on this one. Sometimes you're not. Depends on how the plant's sitting. Good enough.